The universe is vast, it is mysterious, it is also finite. This may come as a surprise. Our minds struggle to grasp the concept of something so immense having an end. Yet, the laws of physics offer clues. They tell a story. It is a story of cosmic beginnings and endings. How will the universe end? It is a question that has captivated astronomers, physicists, and philosophers for centuries. Imagine a detective story on a cosmic scale. We are the detectives. The universe is our case. We have clues scattered throughout the cosmos. These clues are hidden in starlight, in the fabric of space-time, and in the laws of physics themselves. Our goal is to piece together these clues to solve the ultimate riddle, the fate of the universe. This is a journey that will take us to the edge of our understanding. We will explore mind-boggling concepts. We will delve into the bizarre world of dark energy. We will confront the ultimate fate of stars, galaxies, and even time itself. The answers we seek are shrouded in uncertainty. However, the pursuit of knowledge is a journey worth taking. It is a testament to our insatiable curiosity about the cosmos and our place within it. To understand the end, we must first understand the beginning. The universe, as we know it, began with the Big Bang roughly 13.8 billion years ago. It was an event of unimaginable energy and density. From this primordial soup, everything emerged: stars, galaxies, planets, and even us. Since that explosive beginning, the universe has been expanding and cooling. Think of a balloon being inflated. The galaxies are like dots on the surface of this balloon, moving further apart as it expands. This expansion is a key clue in our cosmic detective story. It suggests that the universe is not static, it is dynamic, it is constantly evolving. The question is, how will this evolution end? Will the expansion continue forever? Will it slow down and reverse? Or will something even more dramatic occur? To answer these questions, scientists have developed several theories. Each theory offers a different vision of the universe's final act. These theories are not just abstract ideas. They are based on our understanding of physics, our observations of the cosmos, and our best attempts to extrapolate into the distant future. Let's rewind the cosmic clock for a moment. Picture the universe in its infancy just moments after the Big Bang. At this stage, the universe was unimaginably hot and dense. It was a seething cauldron of elementary particles. There were no stars, no galaxies, no planets. Just a cosmic soup of energy waiting to cool and coalesce. As the universe expanded, it cooled. This cooling allowed for the formation of atoms, the building blocks of matter as we know it. Over millions of years, gravity began to exert its influence. It pulled these atoms together, forming vast clouds of gas and dust. These clouds in turn collapsed under their own weight. They ignited to form the first stars. These early stars were giants. They lived fast and died young, exploding as supernovae. These explosions scattered heavy elements throughout the cosmos. These elements, forged in the hearts of stars, would eventually become the building blocks of planets and life itself. One of the leading theories about the universe's end is the Big Freeze, also known as the heat death. It's a scenario that paints a bleak but strangely beautiful picture of the universe's final moments. Imagine a universe where the lights slowly start to go out, one by one. That's the essence of the Big Freeze. In this scenario, the universe continues to expand forever. This expansion, however, comes at a cost. As the universe expands, it also cools. Think of a cup of hot coffee left out on a cold day. Eventually, it reaches room temperature, losing its heat to the surrounding environment. The Big Freeze suggests that the universe will experience a similar fate. Stars will eventually burn through their fuel and die out, leaving behind only cold remnants. Galaxies will drift farther apart, becoming isolated islands in an ever-expanding cosmic sea. The universe will become a dark, cold, and desolate place. It will be a universe where time itself seems to lose its meaning. Section 5. Stellar graveyards, dying light in a frigid cosmos. In the Big Freeze, stars are not eternal beacons. They are born, they live, and they die. Their death throes are a sight to behold. Massive stars collapse under their own gravity. This collapse triggers a supernova, an explosion of unimaginable power. For a brief moment, a supernova can outshine an entire galaxy. Smaller stars, like our Sun, expand into red giants, engulfing their inner planets. Eventually, they shed their outer layers, leaving behind a glowing core known as a white dwarf. Over trillions of years, even white dwarfs will fade away, leaving behind only cold, dark remnants. Section 6. The Big Crunch, a universe in reverse. The Big Freeze presents a universe that ends with a whimper. But what if the end is not a whimper but a bang? The Big Crunch offers a completely different scenario, a universe that reverses course. Instead of expanding forever, gravity eventually wins the tug of war. The expansion slows down, stops, and then reverses. the universe begins to contract. Imagine the expanding balloon we talked about earlier. Now imagine that balloon slowly deflating. That's the big crunch. Galaxies start rushing back towards each other. Temperatures rise as the universe gets denser. Stars collide with increasing frequency. Black holes lurking at the hearts of galaxies feast on the surrounding matter. The big crunch is a scenario of cosmic demolition. It's the universe rewinding its own existence until it collapses back into a singularity, an infinitely dense point, much like the one from which it originated. It's a dramatic and somewhat unsettling end. However, it also presents a tantalizing possibility. Could the Big Crunch be followed by another Big Bang? Could the universe be cyclical, oscillating between expansion and contraction for all eternity? Section 7. Echoes of the Big Bang, a cyclic cosmos. The idea of a cyclical universe constantly expanding and contracting is a captivating one. It's a concept that has been explored in various cultures and mythologies throughout human history. The Big Bounce theory gives this ancient idea a modern scientific twist. In this model, the Big Crunch isn't the end. It's simply the end of one cycle in an endless series. As the universe collapses in on itself, reaching unimaginable densities and temperatures, something remarkable happens. A new Big Bang erupts, and a new universe is born from the ashes of the old. This new universe would be different from its predecessor, with its own unique set of physical laws and constants. Yet, it would inherit some of the properties of the previous universe, creating a cosmic echo across the ages. The Big Bounce theory remains highly speculative. We lack a complete understanding of the physics that would govern such an event. However, it offers a compelling vision of a universe that is eternally renewing itself, a cosmic phoenix rising again and again from its own ashes. Section 8. The Big Rip, when dark energy tears us apart. So far, we've explored a universe that ends in a freeze or a crunch. But what if the end is something even more violent, more absolute? Enter the Big Rip, a scenario driven by the mysterious force known as dark energy. Dark energy is a puzzle, a cosmic enigma. We know it exists. We see its effects in the accelerating expansion of the universe, but its true nature remains elusive. In the Big Rip scenario, dark energy doesn't just drive expansion, it drives it at an ever-increasing rate. It's like hitting the gas pedal on the universe's expansion, pushing it towards a catastrophic finale. As dark energy intensifies, it begins to overwhelm the fundamental forces holding the universe together. First, galaxies are torn apart, their stars scattered into the void. Then, solar systems are ripped asunder, planets flung from their orbits. Finally, even atoms themselves are shredded, their very fabric torn apart by the relentless force of dark energy. Section 9. Unmasking dark energy, the engine of cosmic expansion. To understand the Big Rip, we need to delve deeper into the mystery of dark energy. Imagine the universe as a cosmic stage. Matter and energy are the actors. Gravity is the director, bringing everything together. But what if there was another force at play, a force working against gravity, pushing everything apart? That force is dark energy. It's invisible, it's everywhere, and it's incredibly powerful. We know it exists because we can see its effects. The expansion of the universe isn't slowing down as we might expect due to gravity. It's speeding up. Something is pushing the universe apart, and that something is dark energy. Think of dark energy as a kind of anti-gravity, a force that repels rather than attracts. It's a force that's embedded in the very fabric of space-time itself. As the universe expands, more space is created, and with it, more dark energy. This leads to an ever-accelerating expansion, a runaway train that could ultimately lead to the Big Rip. Section 10. The Big Bounce, a universe reborn. Of all the theories about the universe's end, the Big Bounce is perhaps the most intriguing. It speaks to a deep-seated human desire for renewal, for a cycle of death and rebirth on a cosmic scale. Imagine a universe that is not only vast but also eternal, constantly cycling through periods of expansion and contraction. In this model, the Big Crunch is not the end but rather a transition point. As the universe collapses in on itself, reaching unimaginable densities and temperatures, a quantum bounce occurs. The laws of physics as we know them break down, replaced by something new, something that allows the universe to spring back into existence. This new universe would not be an exact replica of the old one. It would have its own unique set of physical laws and constants. It would be a new beginning, a fresh start. The Big Bounce remains a highly speculative theory. However, it offers a tantalizing glimpse into a universe that is not only vast, but also eternal, a cosmic cycle of creation and destruction without end. Section 11. The most likely end, a universe of possibilities. So, how will the universe end? The truth is, we don't know for sure. Each theory has its own strengths and weaknesses, its own supporting evidence and unanswered questions. The Big Freeze, with its slow fade into darkness, is currently the most likely scenario. However, the cosmos has a way of surprising us. New discoveries could rewrite our understanding. Perhaps dark energy will behave in unexpected ways, leading to a big rip. Or maybe the universe will bounce back from the brink, giving rise to a new cosmic dawn.